Now let's define the plane of Now let's consider the plane of maximum shear. Now this is the plane which is similar to the principal plane, but on this plane the shear stress is maximum. Whereas in principal plane we take the guarantee that the normal stress is maximum and the shear stress is zero. This condition does not apply for the maximum shear plane, and on this plane we only take guarantee that the shear stress is maximum. The normal stress may be present in the case of the plane of maximum shear. So we define like this: on this plane the shear stress is maximum. So to have the shear stress maximum, we'll differentiate d tau theta with respect to theta and equate to 0. Differentiate d tau theta with respect to d theta and equal to 0. So if we solve this equation, we can have the expression for shear plane first, and then we can substitute and we can find out tau max. So the first term will be as it is, minus of sigma x minus sigma y divided by 2 into 2 of cos of 2 theta. Second term will be minus of 2 tau xy into 2 times sine of 2. Now this represents the shear plane. So we have theta s and this is theta s equal to 0. Now we can rearrange this term to write the tan 2 theta s. So we have tan of 2 theta s is equals to minus of sigma x minus sigma y divided by 2 whole thing divided by tau xy. Let's say this is equation number 8. So from this equation you can find out the value of maximum shear stress. So we are getting this result by putting tau d of tau theta, but we are not getting the same result by putting sigma theta equal to 0. So what we conclude is that on the plane of maximum shear, the shear stress is maximum and the normal stress may be present. Now it is known here that tan theta s is same as delta y by delta s, that is representing a slope. So we have a slope of maximum shear which is represented by m1, is given by equation number 8, and this one is our equation number 7, represent the slope of the principal plane. Let's say this value is equal to m2. So if we take a product of m1 and m2, that value come out to be minus 1. So geometric interpretation is that these two planes will cut orthogonally. That is, the angle between the plane of maximum shear and the plane of principal plane is always equals to 90. So if you have a principal plane, then you add 90, you will get your shear plane. So if you have a tan theta s, 2 tan theta s and 2 tan theta p, they are orthogonal, so they make an angle of 90 degree. So angle between 2 theta s and 2 theta p is 90 degree. Therefore, we can conclude that the angle between theta s and theta p is 90 divided by 2, that is 45 degree. So principal plane and the shear plane are specified by angle of 45 degree. That is, the difference between them is 45 degree. So how you proceed? First of all, you calculate using equation number 7 the principal plane angle, and let mark theta p1 equal to theta p. Then you can calculate theta p2 by adding an angle of 90 degree from this. So whatever the first angle will come, you add 90. Then from the theta principal plane 1, you can calculate first principal plane, that is theta p1 plus 45 degree, because the angle difference is 45. And similarly, we can calculate the shear plane number 2, that is also equal to theta p2 plus 45. And if you want to calculate theta s1, then angle will be equal to 90. So you just remember equation number 7, calculate theta p1 first, then add 90, you will get theta p2. And for each of them add 45, you will get corresponding shear plane. So if we show the element inclined at an angle of theta s, then we do have the maximum shear stress. So this plane will represent the value of maximum shear stress, but on this plane we may have a presence of the normal stress, and we can prove that the normal stress are equally divided on both the sides. So there may be a normal stress and there may be a normal stress on the plane of maximum shear. This is not true in the case of principal plane. In the principal plane we only have the normal stress and we don't have any shear stress.
We have developed sigma theta equal to sigma x plus sigma y plus sigma x minus sigma y by 2 into cos of 2 theta plus tau xy into sine of 2 theta. So temporarily we write sigma average equals to sigma x plus sigma y by 2. So we'll replace this term by sigma average and we'll shift this term on the left hand side. So what you get is sigma theta minus sigma average equals to sigma x minus sigma y by 2 into cos of 2 theta plus tau xy into sine of 2 theta. So let's say this is equation number 1 today. And then we have second equation is what? Tau theta. So tau theta is what? sigma x minus sigma y by 2 sine of 2 theta plus tau x y cos of 2 theta. So what is actually element? Element is like this. Now we'll square 1, we'll square this quantity and then we'll add it. Okay, so squaring and adding. So if you square this quantity, you will get sigma theta minus sigma average whole square. Now temporarily we'll say this is A, this one is B. So this one is A square plus B square plus twice AB. So we get sigma x minus sigma y by 2 is the square of this quantity cos square 2 theta plus tau xy whole square into sine square 2 theta. Now we have already done A square and B square. We have to do twice AB. So this one is 2 times sigma x minus sigma y by 2 into tau xy into sine of 2 theta into cos of 2 theta. So I just changed their order, it doesn't matter. Then below this we write down tau theta square. This is equals to, now this time I will say this one is A and this one is B. So is it A minus B? This one is A, this one is minus of B whole square. So we have the first term as it is, sigma x minus sigma y by 2, square of it. This is sine square theta. Then a square of this quantity, that is tau x y whole square cos square theta. And this sign is minus. So it is minus of 2 sigma x minus sigma y by 2 into tau xy into sine 2 theta into cos 2 theta. Now what happened here, on the right hand side, this term is common and this is the identity. So if you add these two terms, it can be taken common. In bracket we left cos square theta plus sine square 2 theta, that is 1. Secondly, we have also word identity here. And here this term is get cancelled with this term. So this will disappear. So what is left is sigma theta minus sigma average whole square plus tau theta square equal to sigma x minus sigma y by 2 whole square plus tau xy square. That's all, because this term is cancelled. So what we do is now we'll shift this tau theta on this side and we get sigma theta minus sigma average whole square equals to sigma x minus sigma y by 2 square plus tau xy square minus tau theta square. And now we'll remove this square term, so this entire term will become under root and it has two signs, plus minus. So we get sigma theta minus sigma average and sigma x minus sigma y by 2 square of it plus tau xy square minus tau theta square, but this whole term will come in the under root side, as well as it has two signs, one is plus and one is minus. Our last step is that we'll shift this sigma average on this side. This sigma average will shift on this side, so I will do here only. This term becomes equal to, so sigma theta equal to sigma average plus minus this term. Fine. We'll replace this sigma average, that is sigma x plus sigma y by 2. So that is my equation. So I will replace this sigma average as this term, sigma x minus sigma y by 2. Sigma x plus sigma y by 2. Now once we have finished the equation of sigma theta, we will go back to the equation of normal stress. That is the, so I think principal stress was defined something like this, the maximum minimum value of normal stress. This was the principal stress. And on the principal stress is the shear stress always 0. Remember this. इसे को हम principal plane बोलते हैं.
Hence put tau theta equal to 0. So we can write that for principal plane tau theta equal to 0. And if we solve for sigma theta, then we'll get sigma max. And if you solve for sigma theta plus 90, you will get sigma minimum. So we'll take the advantage of sigma tau theta equal to 0. So in this equation we'll make tau theta equal to 0. Then corresponding value will be called as sigma max and sigma minimum depending upon the sign of plus and minus. So I will write this value as sigma max. So when I write max, you have to take positive sign, and when I write minimum, you have to take negative sign. And there is no role of tau theta, so we'll eliminate that term. So this becomes the formula to find out the maximum normal stress and minimum normal stress.